The Voyager 1, NASA's most traveled spacecraft, is still traveling through uncharted regions of the cosmos. Nearly 50 years after its launch, scientists are baffled because this legendary space probe appears to be acting strangely and is sending terrifying data back to Earth. Scientists have been interested in learning more about the worlds beyond ever since the Big Bang, and that is what inspired the launch of the Voyager 1 and Voyager 2, among other space probes. The Voyager 2 launched, first starting its journey on August 21, 1977, from the NASA Kennedy Space Center. According to the official fact sheet on September 5th of that same year, Voyager 1 was launched 2 weeks later. In reality, both spacecrafts were siblings and weighed about 720 kilograms, or about the same as a subcompact car. Both of them were launched during a window of unique outer space alignments that causes a slingshot effect to launch the spacecraft from one planet to another. They have, however, had to move at various speeds and on various trajectories, and on December 15, 1977, Voyager 1 was able to pass its identical twin because of this. And ever since, it has been our go-to research for learning about various facts and space-related mysteries. The first spacecraft to do so was this one, when it began its Jovian imaging mission in 1978. It was about 265 million kilometers from our planet and sent a vast amount of images back to Earth. Voyager 1 completed an impressive 100-hour stint beginning in January of 1979, during which it took 3,750 images of Jupiter's rotation to produce a time-lapse movie showing 10 of the planet's rotations. It had passed through the Jovian moon system in February of 1979, and a month later, it had found the tiny ring surrounding Jupiter. Voyager 1 also made a unique discovery when it found 2 new moons named Thebe and Metis. But scientists decided to end the Voyager planetary mission after the Saturn mission was completed and sent before Voyager 1 and Voyager 2 outside of our solar system at a speed of 325 million miles per hour. In January of 1990, the new mission, officially known as the Voyager Interstellar Mission, got underway. Some of the most famous photographs in history depicting the Sun and the majority of the planets were taken by Voyager 1 on February 14, 1990, while it was 6 billion kilometers from the Sun. They are frequently referred to as the Solar System Family Photo. Mars and Mercury, however, are not visible in the images for various imaging reasons. Needless to say, there were 60 pictures in all, bringing the total number of photos taken by Voyager 1 to 67,000. In the end, the spacecraft's canvas was turned off to conserve power and memory before its interstellar mission. In addition to the interstellar probes Voyager 1 and Voyager 2, NASA also operates the Pioneer 10, Pioneer 11, and New Horizons spacecraft. Before Voyager 1 passed by the Pioneer 10 on February 17, 1998, the Pioneer 10 was the furthest spacecraft from Earth. But Voyager 1 continued its journey for a further 14 years before it finally arrived at the interstellar environment on August 25, 2012. Let's fast forward to November 2018. Both space probes have officially left the solar system after Voyager 2 crossed the heliopause and entered the interstellar medium. Voyager 1 is thought to be 14.5 billion miles or 155 AU from Earth at the moment, and has continued to provide us with useful information that no other space probe missions have been able to reveal since it entered the uncharted territory outside of our solar system. They've also supplied information about the heliosphere, which is a protective bubble that surrounds our solar system. The solar wind creates the heliosphere, which is molded and changed by interstellar circumstances at the actual border of the solar system. The places where the solar wind ends and interstellar space begins are called the heliopause. To NASA, the Voyager spacecraft has supplied fresh knowledge about interstellar space. They discovered, for example, that cosmic rays are approximately 3 times more intense beyond the heliopause than deep within the heliosphere. Scientists merged Voyager findings with data from subsequent missions to obtain a more complete picture of our Sun and how the heliosphere interacts with interstellar space. As per NASA last year, scientists announced that Voyager 1 had recorded a humming noise that was linked to waves identified in minuscule amounts of gas found in the near emptiness of interstellar space. Nicola Fox, the director of NASA's Heliophysics Division in Washington, D.C., stated in a statement that Voyager's mission supplied significant information about the Sun and the Sun's influence throughout the solar system. Over the last 45 years, the Voyager missions have been critical in providing this knowledge and have changed our understanding of the Sun and its influence in ways that no other spacecraft can. Each Voyager spacecraft is powered by a plutonium-based thermoelectric power system. As the plutonium breaks, the heat production decreases, and the Voyagers lose power. To compensate, NASA stated that the team turned off all non-essential and several originally considered necessary systems. This included heaters that safeguard still operational instruments from the intense cold of space. However, while the space agency states that all 5 instruments have had their heaters turned off since 2019, the craft is still operational. NASA experts are still puzzled as to how Voyagers can continue to operate in temperatures well below what they were built for. Scientists have also detected something weird going on in the solar system's outskirts. The heliopause, which is the barrier between the heliosphere and the interstellar medium, appears to be rippling and unexpectedly creating oblique angles, but the general concept that the heliopause changes shape is not new. Over the past decade, researchers have determined that it is not static. They made this discovery using data from the only 2 spacecraft to leave the heliosphere. Thus far, Voyager 1 and Voyager 2, as well as NASA's Interstellar Boundary Explorer IBEX satellite, which studies the emission of energetic neutral atoms, or ENAs, produced when solar winds and the interstellar medium interact. In the future, in a nutshell, solar winds and the interstellar medium push and pull on each other to form a constantly shifting boundary. However, recent heliopause research has revealed data that contradicts prior findings IBEX documented. The brightening of ENAs that suggested asymmetries in the heliopause over many months. In 2014, scientists later found such asymmetries were incongruent with the models. That explains why there was such a significant gap between the 2 probes' entries into interstellar space in 2012 and 2018 respectively. They intend to continue investigating the heliopause in the hopes of gaining more information from NASA's Interstellar Mapping and Acceleration Probe. A new and improved satellite that can detect ENAs is about to debut in 2025. We can only speculate on this odd occurrence occurring in the ghostly depths of the solar system. Then in the middle of May, Voyager 1's onboard system that is responsible for keeping its high-gain antenna pointed at Earth, aka the Attitude Articulation and Control System, or AACs, started sending messages home. They were confusing jumbles of data rather than typical reports about the spacecraft's health and status. From our vantage point, it seemed as though the spacecraft had developed a condition similar to electronic aphasia, a condition that results in the impairment of one's ability to speak fluently. It's possible that the data was generated at random, or that they don't reflect any possible state at all. According to NASA's explanation in a statement from the time, the AACs could be even more perplexing for the engineers because, despite the strange status updates from the spacecraft, Voyager 1 looked to be in excellent condition. The radio signal coming from the ship is still strong and consistent, which indicates that the antenna is still aimed at Earth and is not in the configuration that the AACs claimed it wasn't to NASA. Similarly, the space system on Voyager 1 continued to collect and transmit data as usual, even though the AACs were experiencing the same strangeness. Furthermore, whatever was wrong with the AACs did not trigger a fault protection system that is designed to put the spacecraft into safe mode whenever there is a glitch. Fortunately, NASA engineers identified the problem and were able to implement a solution. It was discovered that the AACs had begun delivering their telemetry data through an onboard computer that had stopped functioning many years earlier. While they claimed it is not a serious concern for Voyager 1's well-being at the moment, the underlying culprit must be located and rectified to prevent further strangeness. Voyager 1 has spent the last decade drifting in interstellar space beyond the reach of our sun's magnetic field. The field shielded the craft from cosmic rays and other interstellar radiation. When one of those high-speed energetic particles strike a computer chip, it can cause minor memory errors that mount up over time, and it's realistic to expect that to be a concern for Voyager 1's onboard computers as well. But both spacecrafts are about 45 years old, which is much beyond what the mission plan expected. We are also in interstellar space, which is a high radiation environment that no spacecraft has ever flown in before. The journeys that these spacecraft have taken up to this point has been remarkable in itself, so a small glitch should be hardly an inconvenience. So there you are, guys. What do you think about this strange signal? Let us know in the comments below. If you enjoyed it, be sure to hit the like button and subscribe for more content like this. And as always, thanks for watching.